Hello, it's Scott Manley here with episode 92 of Interstellar Quest. We're closing in on 100 episodes and I'm beginning to wonder whether I will actually manage to get the required warp drive science before the 100th episode. Well, over on Minmus, the nearest thing that Kerbal Space Program has to a comet, Seanlock is flying the Highlander over to the Midlands to try and collect some more scientific data that will, of course, enhance their science program and perhaps give them the vital clues to understanding four-dimensional spatial geometry and therefore the ability to manipulate it with exotic matter. Funnily enough, that's what I've been doing for the last couple of weeks ever since I saw Interstellar and decided to get back into, well, general relativity and figuring out what happens around rotating black holes. Regardless, we don't need to worry about gravity nearly so high, we just need to touch yourself down ever so carefully and of course start collecting that sweet scientific data which is not hidden behind an event horizon or anything like that. Some of the biological samples have not fared well, the metals seem to be doing just fine. The goo wants a bite. I'm not sure how they can tell that just by looking at goo, but I'll take their word for it. Most of the other experiments we have already collected 100% from, but it turns out that there's 125% available, so you need at least two data return missions to get all the science that you can get from every biome. But Seanlock does need to fulfill his flag quota, which of course entails setting foot on the surface, saying all sorts of inspirational words, and perhaps encouraging a younger generation of Kerbals to step foot into space. And of course take a sample in the hopes that this piece actually is the pudding that they all desire. I'm sure he's telling himself that he needs to plant all these flags because of, mass limits and things like that. So what do we say? Probably some smart-ass comment about Midlands and Highlands. Midlands for Highlander. There we go. Words truly worthy of the history books. Now, 8 days into the mission of the John Patrick Mason, we have to make a small correction to our orbit to make sure that we fly past Eve roughly in the orbital plane so that we can pick an appropriate landing site. With a normal mission, we might actually attempt aerobraking, but this thing is going way too fast and aerobraking would involve a lot more braking than I would like. Well, not really so much braking as it would be burning up and braking. So there we go, that's our final encounter locked in. 237 kilometers is good for now. Now it's time to set the alarm clock and approach with great speed and rapidity. Let's see, you can see the planet there. You can see Gilly just spinning around it just up in the corner there. There we go, and we've now crossed, or almost crossed into its domain, but we will momentarily. I don't want to accelerate through the domain crossing too quickly because that will sometimes cause your orbit to change, and it would be unfortunate if I found myself too close to the planet. But that's not the case, so I need to perform a braking maneuver. What I do is I create a maneuver node just to let me know how long it will take my engine burn, and it tells me the estimated burn here is 4 minutes and 51 seconds, which actually isn't so bad, but then again, of course, we want to maximize our efficiency. So if we only burn at 50% thrust, then it will take, 4 minutes, it'll take 8 minutes, 9 minutes, and it will of course it'll use half the fuel, which is brilliant. Later, when we're attempting to lift off from Eve, we may not have the option of running at less than 100%. We specifically chose to use a space plane to lift off from Eve because we can't manage a thrust-to-weight ratio of greater than 1. The real question is how much less than a TWR of 1 can I manage and still get back into orbit. And speaking of orbit, we get to watch a beautiful sunset behind the planet Eve, still slowing down. You see now I'm working off axis to make sure that my orbit is set, and then from orbit we go straight into a descent configuration. So I set the periaps to about 80. I want to bleed off speed as slowly as possible because I'm going to be moving very quickly. We're going to be moving at 3 kilometers per second, probably at higher atmospheric densities than I normally would over Kerbal. We want to be absolutely sure that the spacecraft does not tear apart, and as it happened, this was a very, very long descent. This is about 15 minutes after the initial deorbit burn, and we already start getting problems with stability, so I of course do the usual fuel pumping forward trick, which very few real aircraft can actually do, at least not that quickly. Concorde was an example of an aircraft which did actively pump its fuel around to maintain stability in flight. But generally, real aircraft tend to rely on having the fuel burn at a specific way to make sure that the stability is always maintained. At about 65 kilometers up, we start getting heating from the atmosphere, so I lift the nose up, and what that's doing is that's of course giving me lift, and it's is raising my altitude once again. So we're going to try and maintain this altitude for as long as possible. So yeah, my vertical speed is dropping again. I'm doing this high angle of attack turn. We want to maintain high angle of attack so that we are slowing down quickly. If we just go straight on into the atmosphere, we can glide for a really long time, but we want to slow down. In particular, we want to slow down before we pass over to the night side, because on the night side, we're not going to have any runways, we're not going to have any landing lights, we're going to have to navigate entirely using our eyes and our instrumentation, and we have not surveyed the surface for any any areas suitable for landing this thing. Anyway, things are looking good. We have bled off about 10%, maybe 15% off the velocity without dropping the altitude very much at all. In fact, we are still able to climb a little. What will happen though is that we will begin to reach a point where it doesn't matter what angle of attack I'm using, I'm going to be unable to raise my vertical speed, and so I'm going to start descending into the atmosphere. So about 5 minutes later, I've now dropped the altitude by about another 25 kilometers, and yeah, we start to fly this thing much more like an aircraft. I drop the nose and try to maintain flight status nominal while still having the nose as high up as possible. So we're moving about Mach 2 and still slowing down quite quickly. We want to be careful that we don't descend too fast. You can see the vertical speed is now actually rising as the wing lift starts to become important. We're down to about 15 kilometers. We are starting to experience atmospheric pressure similar to sea level on Kerbal, and have reduced the speed to about 200 meters per second. So we're, of course, much more in control now. It seemed to take forever to descend through these clouds, and I was terrified that I was going to suddenly just see a chunk of land looming out at me. And at about 4 kilometers, we finally catch sight of the land, and specifically we catch sight of a coastline. And a coastline is what we want, because we presume that the coast is going to offer nice long shores, so you can get an idea of how flat things are. More importantly, we want to collect science from both the land and the sea. So if we can land on a shoreline and then slowly move into the water in a controlled manner, we should be able to get all the science that we need from all the biomes. And I have to say, one of the things I am really looking forward to in Point 9 is that all the planets will have full biome maps. Full biome maps actually created by a member of the community, which I'm sure you'll know. The game is of course going from version 0.25 to 0.90 because it's moving from alpha to beta, getting much closer to the actual release, and I'm getting much closer to landing, so time for old me to start narrating. Okay, gear down. We have a fractional air density of 5.5 times normal, moving at 75 meters per second. We would usually be stalling horrifically at this kind of speed, I guess. The only problem, I'm just watching, the vertical speed is still pretty high. That's because of the extra gravity. Bleeding off speed down to like 50 meters per second. Oh, gotta watch that tail. Watch the tail, do not break the engine, and touchdown, touchdown. Okay, all the brakes, apply all the brakes. And, oh god, braking is so much easier on Eve, I have to say. I mean, probably because we have much more friction with the extra gravity. There we go. Brakes! And we have come to a stop. Sonson and Durdos have become the first Kerbals to land on the surface of Eve. What do they have to say? Maybe smuggling some snacks into the command module wasn't a bad idea after all. I suspect that quip is targeted at those that have no chance of returning. So start deploying the cargo bay doors and collecting the infos. Get all the info, get all the science. Okay, and deploy the ladders. We're going to need to do some testing here. Okay, let's see what the material bay has to say about this. And the materials that have not melted are one by one starting to catch fire. This probably has implications for spacesuit design. And the goo says, the goo starts calmly bubbling away, showing me signs of being affected by a magnetic field. Maybe Eve releases gases from its surface to replace the atmosphere stripped away by solar wind. Now, all the other science we should have already got from surface probes that we released from the Eve Explorer. The pressure is awesome, the gravity is really high, mission control, readings are off the charts. Literally, engineers and mission control have hastily appended another sheet of paper. Taking a breath of fresh air is not a good idea according to the atmosphere analysis. This seismic scan reveals a great deal of important information, but none of it says purple. The gravity here makes you feel really fat. The atmosphere of Eve appears to consist of carbon dioxide and nitrogen. Well, it appears that Sonson Kerman has drawn the short straw, and he will have to think up important words to inspire the next generation. Nuts! That's right, Sonson. Encourage the next generation to explore new frontiers of snacks. Now we've stored that important report, we can stand up and from here we can actually take, we can do an EVA report from the surface. You decide to take a short walk, but think the better of it after the first few steps. And even better, we can take a surface sample. It appears that the upper layers of the surface are by far the most purple. Perhaps whatever causes this colour falls as precipitation. That would make sense because the precipitation has clearly fallen on the hull of the spacecraft to let him analyse that. All the same, Sonson, I would really like you to actually investigate the surface here, so carefully head down that ladder. Try not to fall because although it's a relatively short drop, it's a much higher gravity and it's going to hurt a lot more. And, oh, it fell at the bottom. Okay, now, can you get back up the ladder? That's an important test. Uh-oh. Oh, it flashes up the grab, but I can't quite do it. Let's try combining with the jetpack. Jump! No. Yeah, no, that doesn't work. So let's try the other side. The other side might be a little lower. Can we get there? Come on, turn. Ah, there, look, you see? This totally works. Look, he can climb up here, right? So now he can climb up that side, so we can jump off of the ladder. And of course, we have the very important flag duty to perform. Let's plant the flag. Inspire the next generation to go around planting flags everywhere. Unfortunately, given his previous inspirational words, I don't think we can expect much more from him than a simple description of where we are. On the shores of Eve. Of course, we should be aware of the amazing technology that has brought us here. Wow. Unfortunately, he can't spell, so we need to make a little correction there. There we go. That's us. Now, having performed that important piece of science, we'll take a quick dip in the ocean just to ascertain how safe this is. No sense putting the entire spacecraft in there, right? It could be acidic and damage it. So we're going to take a surface sample. Further analysis will determine if this liquid is indeed grape-flavoured, as you hope it is. You have a dream like this once. Unlike the dream, however, this isn't grape soda, and robot dolphins are not swimming in it. Of course, other experiments seem to suggest that this is super dense liquid such as mercury, so I'm not sure I would suggest drinking it. Anyway, another quick run back to the spacecraft. Thankfully you can watch this at 4 times regular speed and then listen to my reaction as to what happened next. There we go, Sonson returning victoriously to the John Patrick Mason, yes, a name which will of course live in... No, it will live in history. Oh, great. Okay, well, at least he didn't explode, which is not, not entirely unlikely given the gravity of Eve. So we gotta try and grab that. Come on, stand in the right place. Come on, get up and climb up. At least you can grab on. That's the important part. I mean, if necessary, I think what's happening is because we are... Oh man, no! Okay, this is a you see, we skimped on those extra ladders at the top. We skimped on those ladders right at the very top, and he's going to be stuck there. So okay, so we can't climb up this side because of the slope. Maybe we can get him up the other side. This is yeah, this is far from ideal. What can we do here? We're going to have to find some sort of solution to get him up that short distance. Oh, he's going to be trapped on the surface. Well, to cut a long story short, we exploit the fact that we have landing gear which we can slowly, lower. We start lowering bits of landing gear to try to see if we can get him up. And, yep, no, it still doesn't quite work. It's like one of those games where you're pulling out the sticks bit by bit and waiting for everything to collapse. Okay, now that last one looked rather hopeful. And let's jump on. Yes! Now the real question is, can he actually climb over this given the angle that it's at? The good news is it does have space probes on board, so we can, or probe controllers, so that regardless we could have flown it back. Whew! There we go! So dump that data in there. And you know what? Now we need to, of course, put these back out. We don't want to try to take off with those. That would be rather unfortunate. Okay, so we want to get back to this lab here, so deploying the ladder will let us do that. But more importantly, we want to actually pull the experiments out of these. So I have to try and get close enough to these experiments to pull the data out of them without accidentally falling into the... No! 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 Come out! No! No! Don't die! Oh, come on. Move very careful. Ooh! I've seen Kerbals explode from being stuck in areas like that because the collision mesh is weird. I've actually seen them get stuck and then shoot off at like the speed of sound. But I think we're okay here. So we collect that data and somehow I need to get over there. I'm going to pull the data from this stuff. So we need to get data from the land, from the ocean. And oh, I should have got it from the lower atmosphere and the upper atmosphere. I forgot to do that. Okay. So I'm going to have to think very carefully about this. Actually pulling the data out of this is potentially lethal. So as long as I can get the data out of here, then I should be able to reset all the experiments on one side, and then we can get ocean and lower atmosphere and then come back for upper atmosphere. Okay, I think this is working. I think this is just fine. Did I get that? Okay, let's get up here. And yes! Victory! Okay, so again, deposit this bounty of science in the command module, and we will then send both of the crew into the lab to actually process the data, because of course we need 2 scientists in that lab to actually reset the important bits and pieces, and then the rest of the science plan can continue unimpeded. So that was Durdos Kerman, this is Sonsen Kerman, and with a fully staffed lab we can science away to our heart's content. Now, having verified that the ocean will not in fact destroy us, we apply some power to those wheels and very carefully try to maneuver the spacecraft into the water, hoping that it will in fact float. If it was mercury, it would float incredibly easily. If it's water, it should float. If it's hydrogen, it should just sink completely under the surface. It's not hydrogen, it's far too hot for that. Well, it certainly makes splashing noises like good old-fashioned water. I just hope we can light up our engines and get out of this later. Let's hope the developer of Interstellar never implemented that particular feature. So it turns out to make the instruments work as if they're in the ocean biome, I had to move a little further away from the coast and raise my landing gear. The materials start to dissolve. The liquid here appears to be acidic. Great! Observe mystery goo. The goo has escaped into the purple liquid and appears to be waving goodbye. Now we need to collect more of the other things. The pressure is very high. You feel lucky you aren't sinking. It's pretty hot. The high pressure is the only thing stopping this ocean from boiling away. You know what? All these science messages, I think they're written by a bunch of people that can't quite agree on what the oceans of Eve should be, and perhaps having it as a mystery is the most interesting thing we can do. Anyway, eventually our ocean science is over, and, well, it's time to light up the engine and very carefully push ourselves back onto the purple land, out of the purple ocean, so that we can perhaps fly into the purple skies and back into the black space. As I said, it would have sucked terribly had I discovered at this point that Interstellar mod disabled the fusion engines while they were in the water. But it appears to be working just fine. Obviously I don't want to accelerate too fast because this is a very fragile spacecraft. If we go too fast we might bounce, we might smash the tail, it might do something that would jeopardize the mission. And there goes the nose rising out of the oceans. It would be nice to have a crescendo of inspiring music at this point, but all we have is someone called Jimi Hendrix playing something called Purple Haze running through my head. And speaking of the purple haze, that will be where we go in the next episode. We will return to the skies and hopefully to space. But until then, I'm Scott Manley. Fly safe.